Okay, so today we're going to talk about Solidity tools and navigating the blockchain, the Ethereum blockchain. It would help if you wanted to play along on your computer. So what I plan on doing today is going through this lab 2.3. So you can bring this up if you've, hopefully you haven't already done it, but what I'm going to do is I'm going to walk through it and then give you an overview of what you're doing. Because sometimes when you do these code labs, all you're doing is like cutting and pasting, and you're not really like trying to grasp what actually is going on. So at a high level, I'm just going to walk you through sort of the play-by-play of getting a Solidity contract, compiling it, deploying it, interacting with it, all of the mechanics of doing Solidity smart contracts, because this is what you're going to be doing for the rest of the quarter pretty much. So yeah, you can bring it up, and I had suggested before you do this lab, I had suggested that you, on the Slack channel, I had suggested that you do this lab, 2.1, because you're going to need a Metamask account in order to do what I'm going to go through today. So with that, let's get started. Actually, we will start with the code lab. What I'm going to do is I'm going to deploy this contract called my contract, and my contract has this source code in it. And if you, hopefully you can see this. Can I make that bigger? It's a very simple contract. It's got Solidity 0.4.24. It's got an owner address that's public. It's got a constructor that sets the owner to message sender. It has this public get balance that is an externally callable function. And it returns a uint, and that uint is basically the balance of the contract. How much contract does this, or how much ether does this contract hold? It also has a cash out function that can be called by anybody. But if you look at how this thing is programmed, when you call this function, it basically self-destructs itself and then sends the ether back to the owner. So deploying this, hopefully you have ether in your faucet, otherwise you won't be able to do this lab. So yeah, create your MetaMask account and then try and get ether into it, and then you'll be able to do this code lab. But basically, the cash out just takes any money that's in this contract and then destroys the contract and sends the funds to the person who deployed it. And then this fallback function, which is payable, allows this contract to receive money. So any wallet can give me ether on this contract. Okay. So what I'm gonna do is I'm gonna deploy this smart contract and then interact with it. So to do so, the first thing I want to do is I'm gonna use my wallet, and I've installed MetaMask, the plugin. And for all of the work in this class, we're gonna use the Ropsten test network. So in this upper right-hand corner, you can click on MetaMask, and the main Ethereum network is here if you actually want to lose money. If you don't, then you can actually use the Ropsten, and this is all funny money, monopoly money that you're going to be doing. There's other test networks here, but for the most part, everything that we're going to do is on Ropsten. So make sure that you set this when you log in to Ropsten, and I'm going to unlock my wallet. And you can see I have 3.4 ETH, and this is enough to do this lab. So the way we're going to deploy, there's multiple ways you can deploy smart contract code onto Ethereum. Truffle is one of the frameworks that a lot of students decide they want to do. I've learned Remix, so I'm going to show you Remix. You are more than welcome to do your program on any IDE for Ethereum that you'd like. So I'm going to go to Remix, and it's just remix.ethereum.org. And you can see the UI is here. This is basically an online IDE. When you add code to this IDE, it stores it locally so that you can get the code when it comes back. So all your developing is going to be done via the web browser. So you can see this file explorer here. And what you have on the left is the side menus that basically give you all the different options, the different tabs in this IDE. The first thing that I want you to do is select your compiler. We're going to start out with Solidity. And you can see the Solidity icon is right here. This is for Solidity smart contracts, so we want to do Solidity to begin with. And then you can see it brings up the Solidity tab here. It gives you different compilers over here. The language is selected. And then right now I don't have anything in here in this file, but this is basically the compiler tab for Solidity. So I'm going to go back to the File Explorer, and I want to create a new contract. So we'll call this My Contract, because that's what the slide says. And I'm going to cut and paste the code that's in here, this code lab, since we already understand what it does. And so I am going to then go back. So this is my file. It's saved. I'm going to go back to the Compile tab, and you can see that this thing is prompting me that I need to recompile this, or I need to compile whatever file I have there. So I'm going to click on the compiler. And there's a button that says compile my contract.sol, but if you look, I need compiler 0.4.24. I'm on 0.5.11. So I'm going to go down and select the compiler that's associated with this contract. And then I'm going to compile it. And hopefully I don't have any errors. And I don't have any errors. But I do have a warning. And so I'm going to click on this warning, Solidity Static Analysis, and these tools are meant to signify what might be wrong in your smart contract. So I'm going to click on this thing, and I look down here, and it says use of self-destruct can block calling contracts unexpectedly. So it does not like self-destruct. And the reason why that warning might be there is, and this is explained in the code lab, the reason that warning might be there is because this is the basis for the loss of 280 million in Ether that was the result of this parity bug, this parity wallet bug. So you can go and you can look at this. It had a self-destruct method that wasn't protected properly. And so when they included this in the contract, someone realized that anyone could kill your contract. It looked like it, and then he wanted to go and test it, and one click was all that was needed to accidentally kill it. And so this wasn't anything malicious, but he's like, hey, I think this is a bug, let me test it. But of course, this particular bug, if you exercise it, it immediately self-destructs the contract. So that might be why this compiler warning is there. You really have to be careful with self-destruct, because if a bunch of people are relying on your code and someone finds a way to call it unexpectedly, then your contract is done. It's basically off of the blockchain. And then you can actually click on this. This is the infamous transaction that DevOps 199 sent to the parity contract. Okay, so let's go back to Remix. One of the things that you'll end up doing a lot of with a smart contract is to work with its ABI not so much its bytecode, but you'll definitely be working with its ABI. And the remix interface allows you to just copy it to the clipboard. So I'm going to just copy this ABI to the clipboard. And then bring up a slide here to take a look at what this ABI looks like. And then paste it. Oh gosh, maybe that wasn't a good idea. Maybe I'll use Notepad. Sorry. So the ABI is the calling interface to any contract. This must be specified so that the compiler knows how to format a call into the smart contract. And you can see it's something that looks like JSON. It's just some kind of structured data format. And you can see things like the function call, this external call getBalance is one of the API, like one of the interfaces that this smart contract is exposing. So you see that here. And then you see that it returns the uint256, which is your balance. Similarly, there's a cache out that doesn't return anything. That's non-payable. You can go down and you can see the, let's see, the fallback function is down here. The fallback function is defined, and this thing is payable. And basically the external interface of that smart contract for you to call is specified in the ABI. Okay, so you won't have to look at the ABI that much in this class, but that's basically what it's for, so that people know how to call your contract. Similarly, actually I want to save that because I want to cut and paste the bytecode. There is this bytecode. So you're going to write something that looks like this, but when the compiler is done with it, it's going to generate this Evm Byte Code. And so we saw earlier when we were walking through the bytecode that each instruction in the EVM is going to be a certain amount of gas. And those instructions are encoded into a binary format and deployed on the blockchain. So what is this going to look like? Well, this is going to look pretty ugly. This is basically when you compile that smart contract that I just showed you, it's going to compile into this. Wait a minute. No, it's going to compile into, wow, it's actually readable. That's the object ID, but then this is the actual program that you're putting on the blockchain. It's actually, it didn't give me the binary format, but that's basically what you're pushing onto the blockchain to execute. Okay. So then what I'm going to show you is I'm going to go back here. So I've compiled my my smart contract. It's not very smart. It doesn't really do much, but the deploy tab is the tab right below it. So after I've compiled it and I've got the green check mark, I'll go down to the deploy. And you can see with the deploy, it knows that one of the contracts that it can deploy is the one that I successfully compiled. There's only one that I can deploy. The environment that you can deploy this on, there's a local Ethereum virtual machine that is implemented in JavaScript when you visit this site. So you could run your smart contract just within the browser using the local EVM. And I'm going to show you that at the very end. But typically what we're going to do is we're going to want to run this on Ropsten is effectively what we want it on. And so we can do either Remix's injected Web3, or we can provide a Web3 provider of our own. Say we're running our own full node. We're going to like, okay, I actually want to point the browser to that full node I'm running. But injected Web3 is like, you know what, Remix, I'll just use whatever you are using, which is the Infura one. So if you want to deploy something on Ropsten, I would recommend injected Web3. And then, of course, it's going to ask you for your wallet address or for you to connect up Metamask, because this Web3 needs to connect up with some wallet in order to interact with the blockchain to sign all the transactions. So this is why I'm authenticating my wallet on this particular, when I select this particular environment. So I'm going to connect. And you can see for my wallet, I have two accounts here on my my wallet. Whoops. So I have an account that's got 1 ETH, and then this is my default account. And my default account, and you'll see this everywhere, is that address. And on Remix, you can see that it has found my wallet address, and this is the address that it's using to do to fund all the transactions that I'm going to put through Ropsten. Let's see. So I can actually now deploy this contract, and then it's going to ask me to fund the deployment using my Metamask account. So that's what I'll do. So this is the transaction, and you can see to deploy this contract, it's going to cost me some Ether, and this is the estimated amount that it's going to cost me. You can edit this this transaction and what's going into it. You can actually look at the data that you're sending as well. This is the Evm byte code encoded in binary. So those opcodes that we saw earlier, that's basically what is stored. This is what gets stored on the blockchain. So the details here, so it's you see it's 508 bytes, that smart contract. One of the things, whenever you submit a transaction to Ropsten, you can vary the amount of gas and the gas price that you want to pay. So in this case, if I edit this transaction, you can get this UI. Metamask is going to try and guess the amount of gas and the amount to pay for per that gas to make your transaction go through relatively quickly. And you can see the average time to get this transaction through is 1 minute. If I want to be a cheapskate, I can wait 15 minutes and pay, basically an order of magnitude less. But if I want to splurge and I want it to go fast, and I want this to go fast because I'm trying to do this live, I'm going to pay extra. And this is the market rate of how much I want to pay for the computation I'm having Ropsten do. So I'm going to have it go fast, and then I'm going to confirm this. And then I'm going to do what we always do on the blockchain, is wait. Wait for your transaction. Hopefully on a Wednesday morning at 8 o'clock, this thing will go through. And you can see once this thing has gone through, you can see that, yes, I have a contract on the blockchain now called my contract. Okay. So you can pull this down, and you can see that these are the external calls that are associated with this smart contract. You can interact with this smart contract directly in Remix because this is where you have deployed it. So I can do a get balance, and there's nothing in there. I can say who's the owner, and you can see it's my wallet address. I'm not going to cash out yet because I actually want to show you some other things. One of the things you can do is you want to sometimes see this transaction on a block explorer. So what I'm going to do is I'm going to click up on Metamask. And Metamask records every single transaction that it has been asked to sign. And you can see here there is a contract deployment, number 322. So I'm going to click on that and see what happened here. If I click on that, let me see in the UI is, it expands out this transaction. It says it's from my wallet to create a new contract. I didn't fund the contract with any initial money. If you wanted to fund the contract with initial money, you could have added, this is the message.value that you could send as part of the contract creation. The problem with this is that the constructor isn't payable. So I would have needed the constructor to have been payable in order to initialize this smart contract with money. But because the fallback function is payable, I can send this smart contract money later on. So now I'm back. Let's see, I want to go back into MetaMask. The common thing you might do with this transaction from MetaMask is, I might actually want to see, so this is the gas price, the gas used, and everything, and so this gives me a log of what happened on this transaction. If I'm interested in viewing it on a blockchain explorer, there's a link over here that says view this transaction on Ethscan. So that's what I'm going to do. And then you can see that this is the transaction hash. It was done 2 minutes ago. There are now 9 block confirmations. That means 9 blocks got added after my contract creation. It's got my wallet. It's got everything I need to debug this transaction. It's got state changes, which is new. Haven't seen that before. We'll actually get to this. So this is the miner that successfully mined it. And the state change of my wallet, because I've consumed some money deploying it, it changes the wallet state. And there's this nonce field that it changes in my wallet. So I've done 323 transactions on Ropsten with this wallet so far. Okay, so that is Ethscan. Are there any questions?
How did you get to this page?
Yeah, versus from here, from the overview, there's a state changes.
No,
Oh, to get to this page itself, this was from Metamask.
yeah.
And this,
Then where did you click?
that arrow right there, view on Ethscan. The other thing you can do is if Remix,
I don't have that.
oh, you don't? Uh-oh. With Remix, you could also, the other way to get to it is the actual transaction. Let me see, the transaction ID should be, wait. The transaction's right here, so you can actually click on this thing too. And then this should give you the exact same. I like you doing it through MetaMask, but you could also just within Remix, in the console, click on it. All right, onward. So we already interacted with getBalance with Remix. The other way you might want to interact with the smart contract is through this thing called MyCrypto. This is an online web wallet. And if you have a smart contract that you want to interact with that you yourself didn't deploy in Remix, then you can use MyCrypto to point it to a contract that you're going to target. For example, the security innovation CTF levels. You haven't deployed that from Remix. The CTF contract has deployed those. You're going to want to interact with these level contracts, and you could do it through Remix, but it's a little more painful. But I want to show you a way of interacting with smart contracts using MyCrypto. So here, MyCrypto allows you to pick a wallet that you want to use for the transactions. So we're going to use MetaMask again. And you can see it's already, because I unlocked my wallet in MetaMask, it already connects up my wallet to this account. What we're going to do is we're going to go to Tools and interact with smart contracts. And we'll say, yeah, we can log out. I don't know why that is there. And so what I want to do is the first thing I want to do is in the upper right, I want to make sure I'm on Ropsten. This has caused students so many problems. It's like, hey, I can't find my smart contracts on Ethereum. If you get to MyCrypto and you can't find your smart contract, it's because you're pointed to the wrong blockchain. So we want to point to Ropsten in this case. And then what I want to do is I want to look at this smart contract I just deployed. And I can copy its address using this clipboard icon. And then I can go back to MyCrypto. Actually, I have a mouse here, so it's easier. And I can say, I want to interact with this smart... Oh, that's my wallet. Let me go back to Remix. All right. sure that actually worked. All right, so that's my contract's address. The thing it needs is the ABI. So this is the JSON interface, which we also have from Remix. So I'm going to go over to the compile tab, copy the ABI, and this will allow my crypto to know how to interact with this particular contract. So I'll paste that in there, and I'll say access this contract. And the contract shows up here, and then I say I want to figure out what get balance is, and I can read from get balance, and I can see get balance is 0. I can figure out who the owner is, and I can read it, and it's got my wallet address. Okay. So then what I'm going to do is I want to send this contract some money from my wallet. So if I click on this, there's this thing called send, or the button called send, and I need to add a recipient. And for the recipient, I'll just use this. Oh, shoot. It's the ABI that's in my clipboard. I need to go back and copy the contract address. Go back to the developer tab. I'm going to copy this, get the value, and then, in Metamask, I'm going to send this contract some money. And one of the things I want to do is I want to take a screenshot of the amount of Ether I have in my wallet. Because we're going to revisit, we're going to see how much this exercise has cost us. So then I'm going to go to Metamask, click send, and then send this contract some money. What? That didn't work. Oh, yeah, of course. I need one of those multi-entry clipboard things. I'm going to send 1 ETH. I'm going to make it go fast, and then next, and then and you'll see that the actual amount, because I have to pay the transaction fee, is a little bit higher than 1 ETH, but that's what I'm going to do. So I'll confirm that, and then I'll wait. All right, so it's been confirmed. This is the transaction, so the amount that was used, the gas limit. This is the limit on how much I wanted to pay. This was sort of an estimate by MetaMask, and then this was the amount that was actually used. I'm going to go click on Ethscan. And you can see the transaction it to this contract. So this is the from, that's the to. This is the amount I sent in the transaction. So I sent 1 Ether, and the transaction fee is there. Click to see more. And then the state changes. I think you'll see that the state change of this contract, it was 0 before, it's 1 after. And then my wallet went from 3.388 down to 2.388. Okay, so that is the contract. Actually, in my crypto, you can actually see that this has changed also, hopefully. And then when you read get balance, or when you access get balance, you can see that my 1 Ether has made it to that contract. And then even in Remix will show that has changed. Okay, so the next thing I'm going to do is I'm going to create a contract. We could actually click on cash out to kill the contract and get our money back, but that would be too easy. What I'm going to do is show you how to create another contract and use that contract to kill the original contract. So I'm going to go back up to the File Explorer, and then I'm going to create a contract called Kill My Contract. Hit OK. And I am going to just go through this source code first, which is all the way down here. So as part of this source code, I need to tell KillMyContract what is the ABI for the call that I want it to invoke in my contract. So the way to do this is you can specify an interface, and the interface is to my contract. And because KillMyContract only wants to call the cashout function, then the cashout function is easy. This is the function prototype of cashout. So then what KillMyContract is going to do is it's going to declare, well, what is the address of the contract I want to kill? And of course, everyone's is going to be different. So when you do this lab, you're going to have a different address than mine. So you're going to have to fill this in with whatever your address is. So in this case, like if I deployed and that was my contract address for my contract, then I would use that. And then what this program does, let me get back to the others. Oh, no. Is that it has a function called kill, which is externally accessible. I instantiate my contract as being an instance of this interface with that address, and this gives me something that I can programmatically use to interact with the contract. And then I can just directly call mc.cashout, and this will destroy my contract. And then, of course, because I define the fallback function, but this contract isn't going to receive any money because when I call cashout, the money is going back to the owner. Okay, so this is a really simple contract. I'm going to copy it and then paste it over. But then I have to fix this contract address here. So I'm going to go back to the Deploy tab, and I have the contract address here. So I'm going to then paste that contract into KillMyContract, and then I'm going to just compile this thing and then get a check mark. All right, so now if I go to deploy, this is at the top. Now I have two things I can deploy, KillMyContract and my contract. Let's see here. So I am going to deploy this contract. And then I'm going to edit it so it goes fast. And then confirm. And then wait. And it's right here. And if I see what this is, it's got the kill function that I can click on to kill the other contract. But I'm gonna do this in MyCrypto, just to show you how you would do this there. I have KillMyContract.sol. I have the ABI. I need the address. So let me see. In MyCrypto, I'm going to copy the contract address. It's not working. What happened to my butt? All right. That's the wrong transaction. So I am actually, okay, I was trying to get the contract address and it wasn't working on that one, so I'll copy the contract here. And then I'll go into MyCrypto. And then I'll do a different contract that I want to access. So that's the contract address. I am going to take the ABI from the compile tab for KillMyContract. I'm going to copy the ABI. I'm going to paste it in here. And then you can see with this ABI, all it has is kill and then the fallback in this ABI. I'm going to access it. And it says there's only one function I can call here, and that's kill. And I want to kill it with, use my MetaMask on this thing. And then this will write out the transaction to the blockchain. So I want my crypto via MetaMask through my crypto to send this kill transaction, which I will, which I'll hit write and then generate this transaction and then send it to the blockchain. And then this is from MetaMask. It says, do you want to do this? And I'll say, yes, I want to send that thing. It'll connect up with MetaMask. I'll confirm that. Oh, well, hopefully that thing goes really quickly. And then you can check on Ethscan this transaction. So it'll sit here and it'll be pending. And then this will go to success, hopefully, after 30 seconds or so. And there we are, successful. So one of the things that you can see is that because of this transaction, this resulted in a transfer from, this is the address of my contract, back to my wallet. And then the self-destruct of my contract is the result of this. So you can go with this transaction, you can click on the internal transactions, and you can see that this transaction has caused some internal transactions, and this is the self-destruct, the suicide of the original my contract that sends an ether back to my wallet. The state changes as well. You can see the state change as a result of this transaction will give you the 1 ether back into this wallet. Okay. And then I'm going to check the wallet again. And then you can see I got my money back, kinda, but it did cost me. So it cost me 0.0005 ETH. Wait, no, 003 ETH. 2.5. Yeah, all right, I can do math, maybe. 2.5, 3.5 ETH, yeah. All right, that cost me money to run. But hey, what the heck, it's monopoly money. All right, are there any questions about that? Yeah.
On the internal transactions page, tab on the last page you're on, the self-destruct said it had a gas level of 0, so that never costs gas to do the self-destruct call.
Apparently not. Yeah. 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 That's because you're asking you're asking all the nodes to delete state, which actually maybe they should be refunding you money because you're clearing out state. But yeah, it's 0 cost because you're actually pulling it from. So then the block it can clean up the state that it would, like when you're running a full node, you're keeping track of the state of all the contracts. So this particular one you can now get rid of. The transactions are still there. If you're running a full node, and you have an archive of all the blocks, then that will be there. But for example, a light node, all of a sudden it can just put a stub there that says nothing to see here. And actually, if you go back, this is the other thing I wanted to show you. If you go back to the deploy, and then you're like, oh, let me see if this contract still allows me to get the balance. It's all cleared out. So then you can see that, in fact, it should say, yeah. But basically, there's the contract. I could send this, but it won't work. But the contract is the original contract is gone. Okay. The last thing I want to show you so after this, I want you to actually go and do more Solidity, and you could actually do this code lab, because the code lab, when you walk through the code lab, I ask some questions and I want you to take some screenshots, so you can just go ahead and do this. The other thing I wanted to show you is that you can actually use this JavaScript virtual machine to test out any smart contracts before you run them. So I'm going to click on the JavaScript VM. And one of the things that you'll see here is that the accounts are all different, right? So it creates fake accounts for you to navigate this virtual blockchain. And I think these things, so you can see each one of these has 100 Ether for you to start with. So let me, instead of deploying on Ropsten, let me recompile my contract. Recompile my contract. And then I will deploy this on the JavaScript VM. And then it instantly gives me that my contract has been instantiated on this particular address. And then I have the get balance and then the owner. Actually, hang on a second. Let me see if I can deploy this thing with some Ether. And it probably says I am not payable, so. Oh, all right, so let me change this. I'm gonna make this thing payable. And then I'll recompile. And then I'll go into deploy, and I say, okay, I want a fund. Oh, well, that cost me. All right. All right. Let me deploy this with. Since I have 100, maybe I'll deploy it with 50 Ether. And I'll deploy, and then it'll give me this contract, and I can do a get balance, and I see I have 50 Ether in this contract, and then the owner is the wallet I used to fund this thing. And then you can see that it's deducted my Ether. And then I can go and back to the Solidity compiler. I'll go to kill my contract. I need to copy the address here so that I can then put it up here to kill. And then I'm going to go back to the compiler and say, okay, I'm going to compile, kill my contract. And then, now I have kill my contract. I can deploy this one. And then kill my contract has this kill function, so I'll hit kill. And then you can see with my contract, if you do a get balance, it says failed to, because the contract is gone because it's self-destructed. And then if you go back to your wallet, you can see you got almost all of your Ether back. So if you want to test and debug your smart contract within Remix, the JavaScript VM in there allows you to do that. And then you can get more detailed debugging information. If stuff doesn't work, you can get the input, the outputs, the log file of it. So that's all I wanted to cover today. Are there any questions before I have you just go off and muck with the blockchain? I would imagine, given the speed at which I was able to do all this stuff, mornings are really good for doing your Ethereum homework, your Ropsten homework. So I would suggest we're going to have a lot more class time to be doing stuff. So yeah, this is going to be good this quarter. And it looks like they fixed Ropsten from 3 weeks ago when it was broken. So, all right, keep your fingers crossed. Knock on wood. Let's make sure this thing stays up. All right, so that's all I have.